The purpose of this webinar is to explore the low-flow hydraulics calculator in the HY-8 program. The user should already be familiar with the HY-8 Culvert hydraulics analysis program and know how to create a new culvert crossing. The low-flow calculator will use an existing culvert crossing, which is analyzed to report to the user the velocities and depths across the cross-section of the culvert at the point of lowest depth and highest velocity. The method is based on a Turner-Fairbanks Highway Research Center report titled Fish Passage in Large Culverts with Low Flows, which is included with HY-8. We will go through two examples in the low-flow calculator. Clicking on the low-flow icon will open the low-flow hydraulics dialog. Notice the left side of the dialog shows a list of the steps included. Along the bottom, starting from the left, there is also a Help button, several computational navigation buttons, and a Save to File button for saving your progress. If we attempt to advance to the next step, then we will see the Data Validation dialog. It is here to ensure that all the necessary data is entered in before continuing to the next step. We will need to specify the lowest and highest flow that still provides passage for aquatic organisms, as well as a peak flow. We'll leave the low flow at the minimum, enter 8 CFS for high flow, and set the peak flow to 50 CFS. If you need more information on how to determine these flows, please see the HEC 26 document made available on the FHWA website. The threshold values are used to give an allowable range of values for the results. If used for the purposes of fish passage, these would represent the maximum swim rate and minimum swim depth of your fish. If you are using it for scour effects, it would be the critical velocity of your sediment. It is the maximum velocity that is allowable for you and the smallest depth allowable for you. Enter 5 for the velocity and 6 for the depth. To understand this last parameter, it is necessary to understand what the calculator will be doing. It will divide up the culvert into slices along the cross-section and then determine the depth and velocity for each slice. It is similar to gauging a stream, where you divide a stream into sections and measure the velocity in each section. But this is done digitally within the culvert. First, because of symmetry, the culvert is divided into half. This half span is then divided into slices. The more divisions you enter, the more slices you will have. More slices will take more time on slower machines, but will provide more data. More data is hard to sift through and understand, and there is a limit at which more slices don't provide data that is more useful or accurate. If you are using this tool to determine aquatic organism passage, we recommend that you size your slices to the organism. A 3 to 4 inch slice yields good results without too much data. The number of slices may be easiest to adjust after viewing the result table. We will revisit this parameter later. Notice it skipped the gradation step because the culvert is unembedded. Our next example will have embedment. This dialog is the Align and Size Culverts dialog. The spreadsheet on the left is the same spreadsheet from the Edit Input Data dialog, which allows you to change the size, elevations, and stationing of the culvert. The right spreadsheet shows results from the low flow analysis with the width of flow in the culvert that meets the entered thresholds, as well as the highest average velocity and lowest depth computed at a slice at the low and high flows. The final dialog shows the results from all of the calculations. The upper spreadsheet gives results to the culvert generally, while the lower spreadsheet shows the result for each slice. There are also plotting buttons below both spreadsheets. HY-8 determines the point along the length of the culvert that has the lowest depth and highest velocity. Then, using this value, the velocity of each slice is computed according to the curve selected for the conditions. For more information on these curves and the method, see the Turner-Fairbanks Highway Research Center report titled Fish Passage in Large Culverts with Low Flows, which is included with HY-8. The curves are listed on page 91. The first 3 results in the upper spreadsheet are the hydraulic results at that location along the culvert. The next result is the curve that is selected, then the width of each slice. Finally, it reports whether the threshold was met. It reports these values for the low and high flows. The final reported values are the threshold velocity and depth entered by the user in the first page, which are reported here to aid the user in comparing the results in each slice. The slice table is set up with the leftmost column corresponding to the leftmost slice, and each column to the right representing the next slice to the right in the culvert as you approach the center. The most right column is the slice closest to the center of the culvert. The first row gives the distance from the left wall of the culvert. The second row gives the computed velocity of the slice, with a shade of green if it is below the threshold and a shade of red if it is above the threshold. The third row gives the computed depth, again with a shade of red if it is below the threshold and a shade of green if it is above the threshold. The final row gives the result of the threshold in the slice, with red indicating failure and green indicating success. Now, to see the difference of divisions, let's go back and change the division to 400. Now let's change the division to 4. Now, let's look at an embedded example. This time, HY-8 went to the gradations page. This step is still optional. If included, HY-8 will include calculation to aid the user in determining whether the selected gradation will be stable under the high and peak flows. The user should only enter a gradation if the culvert is going to be embedded with artificial riprap or natural alluvium. The D5, D16, D50, D84, and D95 values can now be set for the gradation. Now we can select a method to compute the Manning's N. The options available are given by the name of each method's author. There is more guidance available in the help file. For each computed value, HY-8 also reports whether the criteria required for the equations were met. There is also the option that the user may override the computed value and specify a value instead. Here again we have the Align and Size Culvert step. Be sure to double check that the values entered here are correct and that the stress checks in the parameters section are okay. And now we can view the results from the low flow analysis. Note that the results give the threshold as being too shallow or too fast and shallow. The list on the left allows us to easily go back and forth between steps until we find a design for the culvert that meets the necessary threshold values. This concludes our tutorial on the low flow hydraulics calculator in the HY-8 program. You should have learned some of the basics for using the calculator, as well as becoming familiar with the user interface. If you'd like to learn more, please visit our website at aquaveo.com.